Hi everyone. In this video session, we will see the social network analysis, how the various social networks they are connected to each other, how they are getting to connected to each other with various relationships and all. We know that social network it is a website that brings people together to talk, share ideas and interest, or make new friends. This type of collaboration and sharing is known as social media. There are various types of social medias are available. Day-to-day work, the millions and billions of people they are accessing their business through the various social media like classmates, divine art, divine art, Facebook, Google Plus, Instagram, LinkedIn, Mastodon, Mix, MySpace, then Pinterest, Reddit, Tumblr, Twitter, Yak, YouTube, like that. There are so many social networks are available today. Through one network to another network, the people can connect one to each other. Why do people use social networks? First of all, help the people it keeps connected with their friends and family. Second thing is sharing of their thoughts and messages. One can easily share their thoughts and messages from one to one. Social network it is a process of investing social structures through the use of networks and graph theory. It characterizes network structures in terms of nodes, individual actors, people, or things within the network, and the ties, edges, or links that connect to them. There are so many people they can individually they can connect one to one that they may have the various links and that informations can be shared through that links. Here, basic graph theory is adopted in this social network. It becomes a social network analysis. Social network analysis is a graphical representation of relationships among people and or entities. It is the art and science of discovering a patterns of interaction and influence within the participants in network. It can connect subnetworks. So here the social network in analysis, the social network analysis, there are so many participants, they can interact with each other and various link pattern and that node pattern can be used here. It refers always subnetworks. You can consider here there are two sites, site 1 and site 2. They are connected. The site 1 is one intranetwork, site 2 is another intranetwork. Both intranetworks are connected through different IP addresses over network name. So this node 1 and node 2 are intranodes. Here node 3 and node 4 are also intranodes for site 2 and site 1, site 2 respectively. Here node 1 is connected to node 4. It is internet connection. So here this subnetwork refers to how the social network analysis can be done from one site to another site. There are two primary types of network topologies used in generally in this social network analysis. One is a ring type and hub spoke. The ring type is a ring form. The various nodes are connected serially one by one. But in hub spoke, you can see that central node are connected to various side nodes. Ring network is a network which has got, say, one enterprises which is connected through some remote SAN, like that. It's connected in a ring fashion. A peer-to-peer email network is a good example on the ring model, as anyone can here potentially directly connect with anyone else. So in practice, these email networks are sparse as people connecting directly with only subset of people. Here you can see peer-to-peer network, how the people can connect one-to-one each other in serially, and also one people can may connect directly to another one. This is a peer network of ring fashion. It is a peer-to-peer email message network is a good example for the ring network. And hub spoke model is not like that. There is a central hub called your blog here, and it is connected from spoke to spoke. Here one spoke cannot access directly another spoke. Here one spoke should go to the hub, then only it can connect to this spoke. So traffic goes like this traffic, and backlink from spoke. So like this. There are two major levels of social network analysis always discovered in the subnetworks within the network and ranking the nodes to find the more important nodes or hubs. One is called finding subnetwork is one algorithm and another is computing importance of nodes. We'll focus mainly on here computing importance of nodes. You can see this network A, B, C, D are the four networks are these four nodes are connected to each other. There are links from A to B, B to A, D to A, C to D and B to C. Here, in this case, node A gets all the influence of node D and half the influence of node B. You can see the that is why RA is equal to 0.5 into RB plus RD. Here A receives 0.5 this weightage from B, but A receives a full point that is 1 from D. Hence, which node receives a response from another node that will be considered as high rank means its link weightage will be high. So similarly, node B, you see, it gets half the influence of node A. Thus, RB is equal to 0.5 into RA. Because here B gets the half the influence from node A. Node C gets the half the influence from node A and half the influence of node B. Hence, RC is equal to 0.5 into RA plus 0.5 into RB. Where node D gets all the influence from node C. You can see node D gets, it receives the information from C. Hence, node D gets the this full influence from C. That is why RD is equal to RC. Now we form the table with this matrix shows RA, the distance is 0, RA to RB having influence 0.5, RA to RC 0 it is again, RA to RD 1 because RA receives here full information from RD, that is receiving node RA, here RD from RD is 1. So RB to RB again 0.5, RB to RB 0, RB to RC 0, RB to RD 0, RC to R again 0.5, RC to RDB is 0.5, RC is 0, RC to RC 0, RC to RD is 0, RD receives nothing from RA, that's why 0, RD receives nothing from RB 0, RD receives full influence from RC, that's why 1 as a destination node, and RD receives nothing from RD, that's RD to RD distance or distance of same node will be always considered as 0. So from this is a table on data set 1. Now let us assume some initial value for RA, RB, RC, say 0.25, 0.25, 0.5 are the initial value of assumed values as an unsupervised learning technique. So RA will be assumed 0.25. Apply this 0.25 RA value in the first formula. We'll get a modified value of 0.375 RA. Take 0.25 of RB and it will be modified to 0.125. Again take 0.25 in RC equation. It will get 0.25 RC. RD also 1. So RC, RD remain same. It never changes. Here you see. Same value will be continued for iteration 1. We got 0.375, 1.25. This will be continued again to calculate RA, RB, RC, RD. In iteration 2, again we got 0.3125, 0.1875, 0.250, 0.250. Say remain same RA, RD. Only RA, RB will changes in iteration 2. Similarly, in iteration 3 also it changes. You go up to some iteration 8, up to we'll get a certain value. RC, RD never changes here. Only some RA value goes certain high, RB value goes less. So after iteration 8, you stop doing this one because after getting certain higher value of one node, lower value of another node, stop this. So the final rank shows that rank of the node A is the highest, that is 0.33. The most important node is A. So lowest rank is 0.167 of RB. B is the least important node here. Node C and node D are in the middle. In this case, the ranks did not change at all. C and D same. Okay. So this in this okay, I will end this session. Okay. Thanks for watching this video.